let you see the way my broken heart is hurting in me. I've got my pride and I know how to hide all my sorrow and pain. I'll do my crying in the rain. We have dog, neighbor. He bark all the time, become us crazy. And our neighbors have before 2 dogs. And look like dogs is suffer. I tell my husband, dog, and today we know that some dog die and another dog suffer. I won't cry, but life continue, and my husband dog Consent continue make free energy motor hunter. So today movie over unity consignment. I don't know these words exactly. Anyways, it's different plan of something. Sponsor of program Doug Consent, director of stage Svetlana Consent. Enjoy the video.
Okay, what she was saying is our neighbor has 2 dogs, and they're always together, and one of the dogs died and the other dog just howls and cries all night, barking when no one's home. But I guess it'll adjust. So I got some over unity here. I couldn't accomplish anything with all these caps. This coil is, you can see, 3 wires, thick wires as the winding, so it's got very low ohms, and its inductance is 0.8 megahenries, small m, big H. And it says when you do what at 60 hertz, what will be the cap value, and they say 793. So I haven't even got that high of caps. I'm going to have to put a lot more in. That's to resonate the coil. So I thought I would do something that I've wanted to do, is just pull out the power from the coil right here, the secondary, and I have the primary once again being powered by this inverter. It's putting in about 114 volts to the primary over here, and the secondary in the middle, or the middle coil is shorted out, and this is the secondary, and it has the power, output power, so that goes right into not a full wave bridge rectifier with Schottky diodes, but a voltage doubler. Here it is. This is if you have 1 volt, you'll get 2 volts DC. So this is a pretty common circuit, because I'm getting about 7.7 volts coming out of this big fat coil here. And so I thought I'd double it with a voltage doubler, so that's what I did. So now I have almost 16 volts. Here's what's coming out of it, 15.54 right now. And I decided to use these super caps. This has a maximum of 16 volts, and it's each of these caps there is in series, and they're 500 farads. So this is about 500 farad worth of capacitors at 16 volts. So I have this parallel to this. And now I also have that stupid LED, but it doesn't flash anymore because I'm really hitting it with some good juice now. Now I'm going to go measure the voltage across the battery that's supplying power to the real inverter. And I'll show you what I'm doing right now. Over here is the battery. It powers that inverter, this inverter here, the real inverter. And it supplies the AC to the primary. Middle is shorted out. Now, the secondary, I have a voltage doubler and the super caps, and then an ammeter to run the dummy inverter. Okay, so what I'm going to compare is the voltage across the super caps and the DC voltage across the inverter, dummy load inverter, and the amps to it. That's an ammeter there. So that'll give you the watts going into the light. I don't care what the AC is or anything. I just want to know what the watts in DC is to this inverter. Okay. Over here, I just want to know what the watts is from the battery into the inverter over here in DC. So I'm comparing DC in and DC out. Okay, so one moment. Okay, coming out of the cap bank to power this dummy inverter to light up this light is 0.88 DC amps. And we have 15.1 volts across this cap, the voltage doublers, and the super caps. Okay. Okay, the output is 15 volts and 0.87 amps. That's 13 watts output. Okay, now we're going to look at the input. Okay, it's 11.8 volts in that battery. And I do not have the light lit. This is without the load. It's 0.5 amps. Now I'm going to plug in the load. Okay, the light is lit. 11.8 volts and 0.62 amps. Okay, I'm going to write that down. Okay, remember it was 11.8 volts coming from the battery. It's 0.62 amps DC. This is DC input from the battery to the inverter, and then that powers the primary. 7.3 watts input. Output's 13 watts via the secondary output into a voltage doubler right here. Here's the secondary output, couple diodes, couple caps, and you get twice the volts in DC. And then I dump that into this super cap bank of about 500 farads, and that goes into an ammeter on the way to the dummy load inverter, and that lights up this light. And the output has a super cap and voltage doubler of 15 volts DC and 0.87 amps into the other inverter. So 7.3 in, 13 out. Whoopie ding dongs. So this is no resonance going on or anything. It's just the secondary output rectified with a voltage doubler into a super cap bank into the dummy load inverter on the DC side. AC goes to a load of an LED light. And I'm just concerned with the voltage in from the battery to the inverter here, and the watts input from the battery to the inverter running the whole show, the real inverter, and the watts output in DC from the cap bank to this dummy load inverter, which lights up the light. So it's DC in, DC out, watts in, watts out. So there's something. Okay, thanks for watching.